Today's teardown is accompanied by Brune Brown Ale from Section 6 Brewing Company. They describe it as tasting of dark chocolate, coffee, and toast. I can believe some of that, but I'm not really getting much toast. Today, I am taking a look at this Cree branded LED light bulb, which has failed. It was in loyal service out on my front porch for somewhere over 10 years, I think. But it has stopped working all of a sudden. There you saw a little bit of a flicker when I screwed it in, but then nothing. So I'm wondering if it's a simple failure or if this thing is completely toast. Just for reference, this is an 800 lumen 9 watt 120 volt light. Claims to be 5000 Kelvin. And I thought it was going to be difficult to take apart, but this putty or whatever it is that was holding it together just fell apart. And I just noticed that fell off. I'm assuming that's an LED. Yeah, there it is there. This may be an easy repair, or at least a very obvious failure mode. So there is a circuit board wrapped around this central aluminum column here with these aluminum heatsink fins here all connected to that. I think that looks like a little, that's just a spring contact there. And I see this little plastic clip in here. So I'm wondering if this board could just slide out. Wasn't expecting it to be that easy, but yeah. That board just slides right off the top there. Well, that is cool. Now then, I have to make sure that these contacts go to the right spot, I think. That one is marked positive, so I'm just going to put a little bit of red tape there so that I remember when I'm putting it back together later. So that just slides that entire LED board off there. So I'm guessing that all of those LEDs are probably in series between our positive pad there, our negative pad over there. Looking closer at that LED that popped off, it appears that there are at least 4 sections in it. Maybe more, it's kind of hard to tell, but I can see at least 4 in there, which would suggest that it's about a 12 volt LED. So with 10 of those, about 120 volts, give or take, across the whole thing. So I think we might be able to see that, although open circuit with no current regulation, it's going to be higher, probably. Let's find out. There it is down there, and that one there. Yeah, so open circuit 310 volts. That makes sense. And if we measure just from there to there, that's measuring voltage through the whole bunch of them. Oh, we're getting about 125 volts. And based on the leakage through the meter, we're getting just a slight glow off of those ones, and it drops down to about 130 volts dropped across all of these, although that's at a really low current. I don't know if I can solder that one back on there or not. I think that might be foolish, and given that this thing is ancient, I had forgotten how long I've had it, but it was made in 2012, or at least the silkscreen was designed in 2012, so I don't think this thing owes me anything, which means rather than trying to resolder that, for whatever reason it fell off, I think I'm just going to dive deeper and see what's down in here for a power supply. So as I mentioned, this glue became brittle on here, which is why the lid popped off in my hands before I even really tried taking it off. So just snap that stuff right out of there so that I can get to these 3 locking tabs there, and then one up at the top there. And just pry those little tabs out of the way, and oh, I was expecting wires. That's got spring tabs going onto the board down here. Interesting. So let's just pry that back up and off there again, and I think then just push that tab out of the way, Is that pushed down? Yeah. So that piece in the middle there is just a plastic carrier for those two spring terminals that go up onto here. That's very modular. And then there's the power supply down in there. We have an inevitable piece of Kapton tape, just protecting that capacitor down there. Another capacitor. Okay, how does this come out? And can it come out non-destructively? One wire is just soldered onto there, so maybe I can knock that solder off and get at that wire. I don't know, but I'll try. Maybe that'll come off now, possibly. Now to see about this. Is it a button like so many of the ones that Big Clive shows? Or is it more soldered down like we're used to here in North America more often? Oh no, it is that little rivet mode, which broke off. So maybe now that will come out. Yeah, the bottom layer is coming out. This one here isn't, though. Looks like I'm just going to have to force that one out. Okay, so there are our two wires. There's the neutral and there's the line. The line went right at the bottom. So what do we have packed in here? 3 capacitors on the side. No, those 2 are capacitors, clearly. That one is labeled as an inductor. And on the other side of the board, another one of those inductors, a couple more capacitors, another inductor, and 3 bits of silicone and a whole bunch of little resistors. Wow. And surprise of surprises, an actual fuse, a 500 milliamp fuse. I don't know that I've ever seen that in an LED light bulb before. That is just wild. Obviously, with the number of components that are in there, I'm not going to do a full schematic of this thing. Those traces are buried under too many things, and there's just too many components. But I will see if I can get any numbers off these larger guys. So after spending a little bit of time with this thing, there's a few chips and a few devices that are identifiable, and at least the first part of the circuit makes sense before it disappears into the maze of tiny components. So we have the line coming in there and the neutral coming in there. Those each go through these 2 series inductors, which makes sense for noise and whatnot. The fuse is in line with the live first, so it goes live, fuse, inductor, and the neutral just goes through that inductor. And then from there, they both go directly to this little 4-pin device here, which is, to nobody's surprise, a bridge rectifier. Specifically an HD04 surface mount 0.8 amp bridge rectifier. The 04 designation means it can handle a 400 volt peak inverse voltage, and where are we here? The forward voltage drop is only 1 volt. And after that, the traces just disappear under components in various different directions, and it becomes hard to find. But that aside, the next device beside it is this ST branded L6561D, which is a power factor correction chip. The more I look at this thing, the more I'm impressed with it. I mean, the fuse itself was impressive enough, but it's got power factor correction. That's pretty good. Now, I'm not going to go through this entire data sheet, of course. It's a bunch of pages and it's got a fair bit in it. But it does have a sample circuit, which, let's see now, not exactly, although I'm guessing that inductor there is the big one in the middle of the board. Looks like it's got a Zener diode as a reference. And MOSFET on the output side. That all kind of makes sense. Let's see if we can find any of these other components on our board. So as mentioned, that is probably the inductor that we saw beside it. And I'm wondering if that is the MOSFET 3N40K3. Another ST device. Yeah, an N-channel MOSFET. Okay, it can handle up to 1.8 amps, which is way more than is needed for this puny little light bulb. 400 volt capable, so even at the, what was that, 300 and some volts that we saw after smoothing and everything else, open circuit, it's fine for that. And then beyond that, we have these two, those polyester capacitors. They're fairly high voltage. That makes sense. Whole bunch of little tiny resistors in there, and a couple of diodes, one capacitor, and then there is this 10 microfarad 315 volt Nichicon quality capacitor brand. That is right across the output terminals there and there, and that will be the final smoothing before the voltage gets up to the stack of LEDs here. I suspect that this was a fairly pricey light when I bought it, back, what was that, almost 20 years ago now? I was thinking 10, but this has been in service outdoors, Canadian winters, Canadian summers, which, for those of you who haven't been in the neighborhood, Canadian winters are famous. We can get easily minus 35 Celsius without wind chill calculated into it in the winter for months at a time. And in the summer, we have already this year seen plus 32 Celsius. So it has served me well for the 20-ish years of its life. And the fact that LED falling off is the only real failure on it. I wish I had bought more of those, quite honestly. But anyway, yeah, that I don't think I would be able to get back on. That would probably need to be oven reflowed to get it to stay on there. And on an aluminum-backed PCB, oof, another one just fell off. Another two just fell off. Yeah, on an aluminum-backed PCB, another one fell off. Geez, okay. Yeah, now this thing has served me well, but it is ready for retirement. Wow, there's only 3 that didn't want to pop off. Yeah, so I think that's where I'm going to leave that. I might salvage that capacitor because it's probably a good one. Other than that, yeah, I don't know what else to say about this other than thanks for watching. I appreciate it. Questions and comments down below. Nice quick little video tonight. I'll talk to you later.